right, everybody, let's get started. Welcome to Tokyo Rust Meetup, Christmas break edition. This is the last one of the year. How's everybody doing?
Come on.
Good.
Very jolly. Really good. Very merry.
Very good. Okay. I'll do my usual little spiel. So, my name is Matej Kovac. I'm a software engineer at Braid. Braid is helping us organize this event, so we're very thankful. If you want to learn more about what we do, just go over to braid.tech. And now we're going to have community announcements, and you can say things like we are organizing a Rust hackathon, or things like we're hiring Rust developers and we want to pay them a lot of money. And then you can come up here, I'll give you the mic, and you can say your announcement. Any takers? Nope. All right. Yeah. Then I'm going to start with a confession. So there are a lot of things in this talk that I'm not really familiar with. I've never really used labels in any serious capacity. I've written maybe one macro, and I've never written unsafe code. So that's just to say, if you feel like a little bit lost at any moment, don't worry. You're probably not alone. Just ask a lot of questions. I'm pretty sure Remy will appreciate it.
It's okay if we don't reach the end of the talk. Just ask away. It's fine.
Yeah, so basically, bottom line, don't be shy. Ask questions. This is all supposed to be interactive. And just to give you a little story about how this talk came to be is the last time we were having the coding together session, Remy came to me and he asked me, hey man, you want to see some crazy stuff? And then he did not disappoint. So yeah, without further ado, give Remy a very warm welcome.
Hello? All right. So my name is Remy Clarke. I've been recently working as a Rust programmer for Scylla Digital. And I started out about 3 years ago just doing programming as a hobby. And I would keep doing cursed stuff, annoying people on Discord. And eventually you learn stuff. And I'm here to show you some ideas. I think what's most important with what we're going to have a look at is that this isn't a talk about how you should write your code, but that there are more parts of Rust that you may have been scared to explore. And that you can ask yourself, well, why would this thing exist? When can I use it? Can it solve an issue I have, right? So if you look at it and you feel sick to your stomach, that's okay. That's okay. Just so let's get to it. The first thing, oh my, all right. So the first thing is I've put this in the Discord chat and also in the Discord and also in the meetup stuff. I put the notes that I made for myself for the presentation here on this GitHub link. And it actually has, you'll notice here it says like labels 1 and like labels 6 and macro 1. So if at any time, if you happen to be looking at this or we come to the presentation, you're like, well, can we look at this part? You just tell me where that label is with the number or the and we can go back to that. So let's get to it. One thing that we're going to have a look at is the whole time I show you stuff here, there's one thing that's going to be consistent is to remember that all this stuff happens locally. So it's not part of your public API. It's something you do inside of your implementation that helps you solve problems, right, without making things more complex outside of there. So, for example, we'll get to it, but labels only exist within a function's scope, right, for a loop. They don't exist as part of your API. I'm going to show some stuff where you have a macro that you define in a function, like inline, specifically because it has more power inline than it does if you make it exported. And then, of course, unsafe code, gives you lots of abilities and powers to do stuff. And obviously, you don't want an unsafe interface. So let's just kind of try and remember each time that we see stuff here that everything should be as local as possible, right? So the other thing, just to challenge you, and also because when I'm doing my own code in my own time, I use no implicit prelude at the top of my file. This just helps me learn the standard library. So does anyone have an idea what the prelude is? Who doesn't know what the prelude is? You don't know. OK. So when you start a Rust project, there are things that are already imported for you, and even more so if you use cargo. Specifically, your crates are automatically, you have like this extern crate that you don't have to write for yourself for all of your dependencies. So when you do no implicit prelude, you actually have to say where that crate has been imported. And the standard library actually originally used to be just one library, std. But then they learned that they had to do stuff for embedded developers, and there was stuff related to the operating system. So they started pairing out parts of the standard library that you can use without the operating system, and that you can use without the heap. So basically, core is where all the fundamental stuff and the lang items and the intrinsics, they're all there. So you can do pointer stuff, you can do all your numeric stuff there. Once you want to use the heap, right? You want to allocate memory, you want to do more fancy data structures. Well, if you can, get yourself an allocator that's good enough for the global allocator, you can start using the alloc crate. And then if you have an operating system or you've made your own and somehow get it working, you can then go to the stuff that's necessary for the standard library. So you'll see in the talk things like, this alloc crate or the core crate. They're actually all, if you replace that word, core or alloc at any time with std, it will work. But it'll give you an idea of like what's more at the bottom of the Rust language, right? So yeah, so you just put this at the top of your file, basically. And yeah, and you'll see some funny stuff like alloc, which is the alloc crate inside the alloc module calling the alloc function. Yeah, it's good fun. All right. So any questions before I, oh, yes?
Can you increase the font size a little bit?
Yes. Yes, I can. Ta-da. Any bigger? No? We're all good? OK, great. So let's talk about labels. So labels, they have them in other languages, but they effectively exist to give you more control over how you get out of a loop, and specifically to get out of nested loops. So for example, common case, you got one loop here, we got loop here, and you got inner loop here, and this one can refer to this one, and this one can refer to this one. So you can say how you want to do the control flow, working down the nesting. And Rust actually has a kind of interesting thing with its labels, which is that you can actually break a value. So a loop can have like an expression, can actually be a value itself, which we'll find later is quite interesting for refactoring purposes. And people are also surprised to find out that for loops, for example, also have labels. I often show this to people, and you can do that. All right. Does everyone understand what a label is or not? Can we? Yeah. Okay. So.
Do you want us to just interrupt you?
Oh yeah.
Yeah. Are fours? I feel bad. I should know this. Are fours expressions in Rust, or can they also return a value like the loop labels?
That's a good question. So that's one reason that even though it increases nesting, I personally prefer the normal loop, because you can return a whole value. For loops and while loops cannot return anything other than unit.
Okay.
Yeah. But it's good to know that you can label a for loop, because often people assume that it just only works over each iterable and it has to just do it. So you have a, yeah. But what's kind of interesting, and I don't know if it's unique to Rust, but it feels that way, is you actually have labeled blocks, which is effectively the same as like an infinite loop with a label, but won't have the semantic of going around, right? It'll actually return a value at the end if you didn't break, right? And the kind of neat thing here is that we can do things like this. We can do a pattern match, and then we can do an else on the value, and break if it doesn't pattern match. which means you don't have to do nested if let, right? You can just say, try and pattern match, try and pattern match, try and pattern match. And this lets you do what, we kind of talk about as happy path programming. So long as things are going good, you're going down. Otherwise, you can go out. And because these blocks, right, are expressions, you can break with a specific value, and that value will go right to your variable. And another kind of cool thing about this is that you might have a part of your function that you want to pull out as a function, but you're not sure, like, what's the scope of the function I want to pull out, right? And what are the values I want to pull out? How am I going to extract out that function? Oh, yes?
What's the B in front of the string constant margin? What does that do?
Ah, good question. So the B is to have a byte string, which means that it's a slice of U8 instead of UTF-8. This just means that you can start writing code kind of like a C programmer, but specifically here, it just lets me have characters, And notice how you have B in front of each character there? That means that's actually 1 byte. So you have the byte that represents ASCII M, byte that represents ASCII A, and so on. And here's another interesting thing that it's not part of the talk specifically. Did you know the dot can actually capture the value in there? So rest here actually represents like the rest of your slice. And you can capture the variable name using @ just like you would inside of a match statement. Pretty neat stuff. Any other questions? Top of the mic? Yeah. Oh my goodness. Amazing. All right. I'll try and remember to direct this mic directly into my face. So yeah, what's kind of neat here is that since we now have this block with some way of control flowing out of it with the value, that sounds very similar to something else we have, which are functions. So you can actually progressively turn a labeled block into a function by first taking the most aggressive way of doing it, which is to turn it into a move closure. And then it's basically the same. You now have to call it afterwards, of course, but this is semantically the same, right? And after we do that, we can turn all those breaks that we had earlier, right? Because earlier, if we compare the two, we had a break that breaks at this label, right? But now, because it's a closure, that could turn into a return. And the return will return for the closure, right? Everyone with me so far? Okay? And now, what's kind of cool is you can now slowly change it to have a fuller type signature, right? And you'll find out that, other was also being referenced in here, but wasn't being passed as an argument. So we can slowly, refactor this to a closure and eventually a function. And now this whole function is safe to just move out of the function, right? So you can have incremental refactoring without, worrying about it not working as you go. So, yeah, that's basically the part on labels. Any questions? Yes?
Why would we use labels in the first place then if we can use it as a function?
Well, let's have a look from the actual code. Notice how, yes, so the question is, why would we use labels in the first place, right? Well, there are a couple reasons. The first is they're fast as hell because, it's inlined. But assuming that we're not worrying about 100% performance, right? And maybe it is actually in some cases better to not have a big old function. And it's, notice here on the last example, I had to write a function with the full signature, and I had to say the types explicitly. And there are more things that are going to go on, but there's a lot of boilerplate that you have to write to guarantee that this function is a valid function. And even in the case of the closure, in this case we might get lucky. But in some cases, it's going to say, well, you're going to have to put the type signature. You're going to have to put the return signature. Whereas with the block, I didn't have to do any of that. So in some sense, it's like it's a better starting point, and then you can decide, that's fine. I'll leave it as a block or I'll leave it as a loop, but then you can go, my function's getting really big, and instead of like having code that can't compile for 15 minutes, right, while you're refactoring it, finding out the signature and all that, you can, stepwise refactor it. So.
Use case wise, like, can this be used inside an API to do some functionality and then?
Labels are second-class citizens. You can't pass a label into a function. Yeah. 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 But, I have a friend. He's been working at Mozilla. He does tons of crazy stuff. I showed him the label block, and he's like, wow, I had never thought of that. And he's been using it. He's happy with it. And it's, like I said, it's more like it gives you just another tool. I wouldn't overdo it, right? There's some times where it just makes sense. Sometimes not so much, right? So, all right.
Would that work without the label? If you just had the scope operator?
Oh, you mean just the break or just the scope?
Just the break and no label.
So, there are two ways to kind of think about that. The first is that, when you generally write code in Rust, you kind of assume you can have any amount of scopes nesting each other, and if there's just a single static value, it just returns the way through, right? Yeah. Whereas if you had a break, how many things does it break up, right? So they probably conservatively said, you know what, if you're going to make it a labeled block, if you're going to use a block to break, it has to be labeled, right? You can try it, but yeah, it doesn't work with just a block. I think there's also I think it's pretty sane, honestly. Yeah.
Because what does it mean? Does it mean it's breaking out of the else, or does it mean
Yeah.
it's breaking out of the, it makes sense.
Yeah, and for anybody who's wondering what this is kind of like is, a lot of people have said, goto is fine so long as it's always down. This is basically goto going only down, right? Whereas loop is a structured way to go back up, right? So it gives you just a little bit more control. Don't overdo it. All right. So, final notes, consider the use of labels, specifically if you have fallible operations and you don't want to have to deal with really fancy error types. A lot of people, they'll use anyhow or Miri or some other library to deal with their error types. And part of that is because they keep trying to refactor everything into a function. They keep trying to deal with every single possible error out there. And they then have to write it out in their type signatures. They make it, and they complain. It's like, well, if you just had it inlined in a function and you knew exactly where it's going to be used, you could have just used a label block. So, yeah, food for thought. All right. Yeah. All right, everyone ready for the next, for some macros? Who here has ever written a macro? Okay. Who here has an idea of what a macro is? Oh, we have more people who've written macros than understand macros. Beautiful. All right. Well, effectively, with declarative macros, you can kind of think of them as a form of code templating, right? But fortunately, Rust has some nice features where they're very careful to make sure that it takes into consideration the identifier scope. So we'll get to that. But let's see a situation that is going to seem trivial, but you can maybe identify with yourself. You got something here. You decide, I'm going to use some labels because Remy talked about it, and you made yourself a match statement. And you're like, well, I got some repeated code here. I got this line here looks really similar to this here, right? I could maybe factor that out into a closure and then maybe call it. But we got a problem. Our vector is mutable and push is taking a mutable reference. And so now this code won't compile, right? Because the closure has captured the mutable reference. And now any other thing that's not the closure that wants to try and use the mutable reference is not going to work out, right? So the problem here is that you're fighting the type system. You tried to abstract the code itself, but you ended up with a type. Does that make sense?
Can you go back to macro 1?
There's no, yeah.
Or yeah, just the, so we can look
So specifically, it's the vector push 1, more code 2, right? We just wanted to pull out that code and avoid the repetition, right? I mean, it's purposefully a short example, but hopefully you can imagine something like this in your own code. So you wanted to avoid copying the code, but you ended up with a data structure, right? And now you have to deal with types, the data structure of closures and so on, right? And a small amount of sadness, and you just decide, oh, I'll just leave like that. But if you use a macro, it just works. Now, this, of course, is not the best example of using a macro, right? And you might be wondering, what the hell is CFG, ATTR, Rust FMT, skip? That's just to avoid it, formatting and indenting everything. But, that's not to be worried about. But now, it will just paste literally that code at the P1 exclamation mark, right? The code itself. And kind of interestingly, it has no arguments. This macro has no arguments. Now, you might be wondering, where are the arguments? Well, normally the arguments would be right here. There are none. And yet, it's able to talk about vector, which is described here. So because the macro was defined after vector, it has access to the identifier scope of what came before. Does that make sense? I mean, I'd understand if people are not sure. Does that make sense? So like vector here was able to be used because vector existed before the macro. That means there's no way for you to call P1 before the macro. It must be called after, right? Now, the power here is that it actually means that the lower down the macro is, the more identifiers it can talk about without you having to pass it in as an argument. Yes?
Perhaps some people might not be familiar with what an identifier is.
Sure. Okay. This is a name that you wrote. That's an identifier. You make a function. It has a name. That's an identifier, right? Does it make sense? And I'm specifically saying identifier because, well, if you ever decide to look into macros and try it out, your macros will eventually have arguments, and those arguments have what are called meta-variable types, which say like what kind of element of code, like are you dealing with an expression, just a token, an identifier. So we'll get to that. But yeah, that's the basics of this. But let's have a look at a hairier example, because you might just think, well, this is kind of trivial, right? So here's our hairy example. It's well, just so you know, at the bottom it's doing a print, okay? But this is pretty hairy. It's got an async function, so we know it's returning a future. That future is expecting a result type. So we already know that in an async function, you can use the await syntax, right? And if it returns a result, you can use the try operator, the question mark. So let's break this down and have a look at a simplified version of this, right? Where we see just before the outer scope. So you see scope here has a labeled block. Now everything if our macro, which is defined right after the opening of this block, right? That means that our macro that will be defined where this comment currently is will have access to the names of maxops, num, operation count, and operate. Does that make sense? Yeah? Okay. So the macro itself has arguments, right? This is slideware. Don't take it too seriously. That's why it's got like punctuation. But Effectively, $ in a macro says, I am a symbol or a token. Like I am an element of code. And in this case, the $ with the star says I am any amount of elements of code. And then it says I have where, right, the first element is a symbol called punct, which is a token tree. And I am a symbol, num, which is a numeric literal. A literal is like laser pointer. Beautiful. Can anyone see the actual pointer? Okay. So, see this here? Okay, so we got like punctuation here, right? And then we have literals that are here. So, does anyone know what a literal is? It's like when you write an actual number or you write a string. It's like where the element of code is the value itself, right? Not some user-defined element. So we can see here it's going to take a punctuation and it's going to paste it right here. And it's going to take a literal and it's going to paste it right here. And, you know, this doesn't look like Rust syntax, right? But you can see it's like it's taking this, and it's going to paste it there, and it's take this and paste it there. So it's going to take this x here and first increment by 2, decrement by 1, multiply by 7, so on and so forth. All right? Questions? Yes?
What does the horror do?
Ah, if we make it to the end of the talk, I can show you its implementation.
Okay, I'm scared now.
The point is that it's kind of horrible because it's taking in an implementation of, it's taking in a closure, and it's actually asynchronous. So it just generates a compiler-generated type that you can't even name, right? So you might think, oh, but couldn't I just put all these values into like an array, right? But they're considered as different types, right? So you can't put them all into an array. And you go, well, how can I make them the same type? Well, you'll have to use a box, right? Well, now all of your values are on the heap, right? You got a lot. This is what I mean by horror. It's like you don't. It's something you just don't want to have to deal with, right? That makes sense?
Yeah, that makes sense. I would like to see the implementation.
Sure, yeah. If we can get to the end, I've got 2 bonus sections that we moved out because a lot of stuff here, right? Yeah, you?
Quick question. So the op macro there is,
Yes.
is that a standard macro?
No, it's defined right here.
Oh, okay. So you're calling itself. I see.
That's right.
All right.
Now, I want to be very clear. We are not expected to ever use op ever again. Okay? You don't export this macro. It's local. It's literally to avoid you writing this many times. Let's actually have a look at what that looks like in source code. So, let's scroll down a bit. And yeah. Oh, this gives an idea of what's in there, but that's kind of, there we go. I believe, oh, that's horror. Well, here it is. So we got our definition here. And I don't know if you guys know about this, but if you actually go here and you're like in VS Code, hopefully your editor can do this too. If you do Control-Shift-B, you can then expand the macro. There you go. It's written, 98 lines of code for us, right? So it's basically inlined this thing for as many of those pairings as it had, right? And the more like normal and typical way of using a declarative macro is to avoid boilerplate would be something similar. It would be like, I've got this complex type that I defined over here, and the code itself is like 40 lines, 50 lines long, but this disgusting macro, let's see, is it going to do it? Actually generates like 1,200 lines of code. So you might go like, well, why would you do this? The point is like, you don't do this if you don't need to, right? But it's there. It's there. So let's go back. Okay. We'll get to it too. But let's say your coworker sees this and they go, "Please no, please remove this macro," and you go, "Okay, I will remove this macro." So you can actually just inline the macro. You can do control dot inline macro, and then go, "Okay, is this better? Is this better?" And well, your coworker will tell you. Sometimes you've gone too far. Sometimes they'll go, actually, it might be all right. But I want you to kind of think about, like this here. Imagine trying to turn this into a function, right? It's like a result of future. It's referring to the outer block, right? It's not like impossible, but what are you sacrificing, right, by saying I want to turn this into a function? But I'm also here to challenge you, so don't take me too seriously. All right. Do we have any questions? We probably have many questions, but yes.
Another question, but for people who don't want to use VS Code, you can also use cargo expand to get a look at the insights of what the macro is actually doing or what it's expanding to.
Yeah, you can expand it before you inline it. Yeah, for sure. And like I said, it's a feature of the fact that this is only used once, right? Hopefully, yes. If you don't use VS Code.
He was just saying cargo expand will do the same thing no matter what editor you use.
Yeah. Did they make that work outside of Nightly? Because for a while that was Nightly only.
I don't remember. I don't know. I only use stable, but I use VS Code. So.
Yeah. Hopefully your editors helps you, with this, right? Because, yeah.
Actually, for reference too, it's not VS Code, it's Rust Analyzer. So any IDE that has a Rust Analyzer plugin.
Yeah.
So anything but corroded or whatever they call it now. JetBrains. They use their own thing.
Yeah, and actually the expand works for procedural macros too, but I'm not going to talk about procedural macros because a whole other can of worms. Yeah. All right. Does everyone at least understand like what's going on here? I didn't even mention the fact that operation count is using a mutable reference. So then you would also have to deal with the mutable reference if you try. So, okay. Everyone good? So, some conclusions, right? Lexical scope is powerful. Oh, yes? Could you speak louder? Project your voice. Yes. What was can you repeat your last sentence?
How do you troubleshoot it?
If you have to deal with types and like you want errors back and all that? I mean, there comes a point where like I said, if you're having a problem, you can inline it, right? Double check it, see what's wrong. Like I said, it's if it's more hassle to deal with the macro than it is to deal with the code just expanded, right? Then leave it expanded. If it's more hassle it's about like what's useful to you. So I would agree. Like generally, if I don't have to write a macro, I avoid it. But it's in my toolbox, right? So yeah, just remember that you want to make sure that your editor, whatever it is, has the ability to inline your macro, because once you inline it, you'll see all the type errors and stuff, right? And then you can just do Control-Z, edit your macro, go back, right? So that's a tooling issue, I would say, Mm-hmm. Mm. Right. Well, like I said, you would. I mean, the idea here is that the macro is local. So you try and make sure that this isn't a problem like some external user is going to use, right? It's a problem of the implementation of your function or other thing like that. And so you find out your case, right? And if it's not working, you expand it. It'll say what line it's at because now it's actual real code, right? Then you can troubleshoot it and decide whether you turn it back into a macro and just edit your macro, or whether you go, it's not worth it, right? Yeah, if it's straightforward, yeah, you could totally do that. Yes.
Are there any kind of triggers for you when you're writing code that you're like transitioning from, oh shit, I'm not going to do this in a function, I need a macro? Like how do you like gauge when you actually need to bust this tool out?
So, I mean, everyone has their own way of writing code, but like for example, one thing I've been doing is I write really fat functions, right? Like, that's one of the reasons I use like labels, is I let it grow kind of fat, and I don't turn it into functions too soon, right? And then at that point, you kind of look at, well, can I turn this into a function? Yes. You see as much as you can do safely, and then sometimes you'll find like, oh, I tried to turn it into a function, but then the lifetimes and the types and everything got complicated. So it's a matter of, taste.
There was a quote of the week on the Rust message board that answered that question. It says, use macros when you run out of language. Rust gives you a lot of language.
Yeah. The one thing I'll say before we move on to unsafe, because like there's more stuff. If you feel like you're writing a DSL, you're not following the sort of pattern I'm suggesting, right? You want to just have it be a way of generating a whole bunch of code at the specific location, right? And not export the macro. If you feel like, oh, I've got 3 match branches and I'm going to deal with little options and default values, you've gone too far. Like, then it's going to be hard for anyone, even yourself, to kind of reason about, well, why did I give myself so much flexibility? Yeah?
I did see a sort of similar local use case.
Yes.
Like this, it wasn't function local, but it was module local.
Yes.
It was in the the SWC code base,
Mhm.
Swift Web Compiler.
Yeah.
They had a tree walker for plugins, for JavaScript plugins. They modified JavaScript.
Yes.
And they had basically the same kind of macro to implement all the visitor functions. So visit ident, visit
Right.
variable, visit scope, visit whatever, right?
Yeah.
Because there was like 200 different visitor functions you have to.
Right. I mean, like, for example.
And so it's a function that's just used once in that one module.
Yeah, like for the things that are just used once, like a really good example you'll find all over in the standard library is, traits don't work in const at the moment. And they wanted to put a whole bunch of functions that are basically the same on all integer types, right? So they made a macro that just does all the functions for all integer types and all the methods, right? And they're never going to export this macro. And you shouldn't, and that's the idea. Like, these macros were originally for that task, right? They were for reducing boilerplate, not for going too far in your API, right? So, and varargs, of course, because Rust doesn't have varargs. All right. So, lexical scope is powerful. Use your macro as low down as you can. And it's okay if your macro is only ever called once. All right, so let's look at unsafe code, because we got more to go, and at some point we're gonna have to eat pizza. So, all right. So when do you think like you'd have to write unsafe code? Well, if you're doing like unsafe code for the sake of just casting a type to another type, that's not really usually that useful. But you're gonna have to use some if you decide to make data structures from scratch. Right? That's the most common case, which means that you're going to do allocation. So I have to ask some questions. Who here knows what allocation is? Who doesn't know? Who doesn't know what allocation is? Okay, good. All right. Does everyone here know what a pointer is? Anyone not know what a pointer is? Okay. Does everyone understand that a reference is a pointer? Okay, great. All right. So we're going to try and just do like a really simple example of some unsafe Rust. And the idea here is that we want to make a safe interface, but we also just want to find some way to like kind of dip our toes into the thing and see the stuff that goes on and see how the type system actually helps us out. So we have a struct, it's my box here, and it just holds a pointer. But implicitly, this pointer points to an allocation, right? And it's supposed to semantically own that as though what it's pointing to was the field of itself. Yeah? Does that follow so far? Yes? I don't see any nodding. Okay, good. No, because this, you know, like I said, this is it's very technical, right? So our struct's job is to hold the value and eventually give it back or drop it. So let's imagine what this thing's got to do. We got to be able to make this thing, so we got to have new, and we're going to put something at the allocation. That's the value that's going to hold a t. I mean, I didn't put the generics on new and unbox, but that's because the struct is generic on t. And then we got to be able to pull the value out, right? That's what unbox is for. We got to have a drop implementation. So it's got to be able to deallocate itself safely if it's just thrown out at the end of scope, right? And you know, just holding a value and giving it back is not that useful. We want to give access to it using references. So we'll do that using deref and deref mute. Everyone follow so far? Yeah? Not so sure. What's not so obvious?
It's 90% follow.
Does the idea that our interface of new, unbox, drop, deref and deref mute, that's straightforward? That makes sense?
It's basically how the regular box works, I guess.
Mostly.
I've never looked under the hood.
Yeah.
So.
Yeah. Well, we'll get to it. So whenever you're making some sort of unsafe data structure, right, the first thing you should consider is how does it deallocate itself? So before even trying to create it, it should safely deallocate. Okay? So we start from drop. So in core ops drop, you might be wondering, why is drop in ops as in operators? It's the curly brace operator. So first of all, you know, to allocate something, to deallocate something, we have to know how big it is and how it's put into memory. That's layout in the standard library. So, you know, in alloc layout, and we're going to make a little constant for ourselves to make our code a little easier to read. Does everyone know about associated constants? Yes? Basically, it's just constants defined inside of the impl block, and that means that you can do like self constant, right? And the cool part is that it's able to use t to find out what that value would be. And after doing that, we implement drop. Oop, let's go. Whee! So at that point, right, what do we got some to deal with here? Now, drop is a little bit subtle, because you probably imagine just drop is one thing that happens. But drop actually happens in 2 steps. It first calls this function, then it drops each field. Okay? So when you implement drop, what you're doing is you're preparing it to be safe to drop each field. Could you imagine how you could like mess this up? If you had a vector as a field, right, and you dropped the vector yourself, right, it's going to try and drop the vector again because it's going to try and drop the fields. So you only just prepare it for it to drop the fields. So we just have a pointer. Pointers don't implement drop. They're like numbers, right? So we want to make sure that the pointer can just be forgotten. So we have to deallocate the pointer it holds. Questions? I know there are questions here. Yes?
What does drop in place do?
What does drop in place do? Well, drop in place effectively does the two-step process of the calling the drop trait function and on all the fields, but behind the pointer. So you can imagine if you do drop in place on a value, use of that value after the fact is bad.
So what you're saying is if T implements drop it. Drop whatever it is contained inside it, and then deallocate the memory that was used for it. So if it's T, if it's like a hash map.
If T wasn't drop, like it was just a number, because copy types don't implement drop, it would just be a no-op.
Yeah.
Right?
But if it's like a vec, then it's a pointer to a pointer. So
Yes.
allocate the second pointer.
Right.
Deallocate, and then now deallocate the first.
Right, because if we just deallocated the memory itself, then whatever the vector was pointing at would just be leaked. Yeah. Or worse. I don't know, maybe it's doing something fancy with like file system handles or something, right? So yeah, we drop what's behind the pointer, right? We have our alloc, dealloc. We drop the pointer with the layout that we allocated with. So at that point, we know that we can drop. And now we can actually make one of these safely, knowing it can drop, right? So pretty straightforward. The sort of subtlety here is that write moves T. It moves the val, right? If it only wrote val there, you would have an issue, but it moves it in. So val will not get dropped at this point, right? So it gets moved there, and then we just return our box holding our pointer. Yeah? So far so good? Okay. Now, you might be thinking, okay, this is a little bit hairy, but maybe you kind of grasp like we got a way to allocate and deallocate, but you're still not confident, and it's good that you're not confident because nobody is. And that's why there's a tool called Miri. And Miri is like a sandboxed interpreter for Rust using an intermediate representation of your code. So like when your code gets compiled, it goes from your source code to high-level code to intermediate, like mid-level code, eventually LLVM, and finally assembly. So at the point where it's halfway through, you can run it in a sandboxed interpreter. And that specific interpreter, Miri, can check if you have undefined behavior. So people often worry that, will my code blow up and I'll never know about it? Well, you can check it. You can check, if you know what the case you're worried about is, you make a test for it. So, you can install it. Then you make a test that has a compile flag for when you're using Miri. So like this is an example of a code that we know is going to fail. Now, if anyone here knows about pointers, why will this fail? Yes, we're dereferencing a null pointer, right? So that's just undefined. And if we run it, it fails, right? It gives us this message saying that you have undefined behavior, tried to dereference a null pointer. So, now we can try that with our two new functions, right? We're going to make a new thing that holds a 5, right? And then we're going to try and drop it. And it works. But there is an edge case that you should always think about when it comes to memory, which are zero-size types. What does it mean to allocate something with no size? It's undefined, right? So we make this test case, and it does fail. So obviously, the standard library makes this work, right? Because you've probably allocated, din trait something of zero-size type, and everything was fine. But what we're going to do to avoid the complications is we're just going to define it out of existence. You're just not allowed to use this type for zero-size type. So what we're going to do is I've just made another associated constant that if ever this thing, can get made and your size is equal to 0, it's just going to fail to build. And we can guarantee that since the only place that you can build this data structure is with new, we just add that and it just won't build. And at that point, this code is unreachable, so we can just ignore it. Unbox.
There's a question in the back.
Yes.
Would Miri be able to inform you if you haven't fully deallocated something, or is that outside of scope?
Could you be more specific about what fully deallocating means?
If you failed to correctly implement the dropping of the box implementation that you're writing, for instance.
I believe if you try and deallocate with a layout that is not the same as the one you allocated with, it will probably fail. But that's what Miri is for. You can write that test.
I guess I'm wondering if, would it be possible for Miri to catch a memory leak, for instance?
Yes.
Okay.
It always checks for memory leaks too.
If you forget to implement drop, Miri will not catch it. That's,
Well, no, it will. It'll catch the memory leak that you allocated and didn't deallocate.
Oh,
Yeah.
that's new.
Yeah. It'll check for aliasing, memory leaks, all sorts of stuff. So yeah, I mean, they basically are trying to make Miri the way of checking all operational semantics of Rust. So yeah, there's a tool there to help you out if you ever want to explore this, right? So yeah, you don't have to just hope that yeah.
Quick question. So you tried to block someone from using a zero-size type by basically asserting it out of existence?
Yes.
Is it possible to use a trait bound to achieve the same thing, or is there
Probably.
another way to do that?
Probably. But, I'm still, although this is safe and I've run the tests and all that, it's still slideware, right? Ideally, you would be able to make the zero-size type work, just like the standard library does. And the solution to that is to use dangling pointers. And the reason it's complicated is because zero-size types, despite having no size, still have an alignment and they can't be null. So you have to make a thing. But the whole point, right, is that you find a thing, make it safe. You can make it more subtle later, right? Make it safe first. Right? So, other questions before we talk about Unbox? No? Okay. All right. So the subtlety with Unbox, right? The subtlety with Unbox is that we're out of time? Shucks. Well, I'd be happy to talk about more of this later. I've put the rest of the notes of the presentation over there. And yeah, I hope everyone learned something. I hope everyone had a good time. And thanks for coming.
So I wanted to ask you the usual questions that I ask people, which is, how did you get into programming?
I did a tiny bit in high school, and then I'm a little dyslexic, and they had us write code in Notepad and then Scratch, and I was like, I think this is not for me. And so I had a thought in the back of my head, this is interesting. I started seeing stuff on YouTube, and then I got interested, and I just slowly just getting more and more into it. And then eventually I was like, well, I keep looking up this stuff. I should check it out. And I, like everybody, eventually, you get a text editor out. You try and find a programming language. I tried a few before stumbling on Rust. Actually, Python, I tried learning C, because I was like, well, I don't want to have to learn another one. But I was like, oh, pointers are complicated. But then I was like, well, I'm not understanding the syntax of this ampersand and star, so I'm going to try Python because everyone keeps saying it's great. I get VS Code working, I get Python, and then everything seems fine until, for whatever reason, the combination of that version of VS Code and that version of Python and the sort of LSP thing they have, it would crash on every else if statement. in every elif statement.
That sounds unhealthy.
So I looked at it for a while and I thought to myself, this doesn't seem like a very robust language. I should find a more robust language. So that is why I ended up learning Rust despite the difficulty.
So your background is not actually in engineering, right? What's your background in?
I studied animation, 2D animation specifically. I mean, I learned some 3D too, but which is like concept and directing and yeah.
So how did you go from there to programming?
You just the internet is infinite. I mean, you just get interested. You start reading stuff, and then I know some people I think a lot of people probably have this feeling is that they're on a community or something, and they hear like you join a community to help you learn some programming stuff, and everyone's like, but how is that going to get you a job? Or what job are you looking for? Or what language? And it's like they keep talking about this, and that's good if that's your goal. But I'm kind of mathematically minded. I'm just really interested in stuff, and I want to know how things work. So, yeah.
What was your first language after you come back to programming?
The first language, technically the first one I wrote any actual code in, and not just like answering multiple choice on a phone app or something, right? Was Python, but like I said, it didn't work out. So then I tried Rust, and I was like, this doesn't seem like it seems like a lot of barriers and stuff. But then once like you've tried Rust, and then you try out, like I was like, well, I want something that's like interesting. So I then tried like Forth, I tried APL, I tried J, I tried Prolog, I tried Haskell. And I tried a bunch of stuff because I was like, well, what's going on here, right? And then I'd keep coming back to Rust because it kind of felt like if I don't understand it in Rust, I probably don't understand it. Because there's so much explicit things you can do in Rust about, as far down as necessary, right?
Talking about things you don't understand, what were some things that were hard for you to wrap your head around in Rust specifically when you were learning it?
There are a couple things that just require a bit of experience, and then there's also just realizing that certain tools really are for specific problems, and trying to apply it for everything doesn't always work. I think in some other languages you can kind of get away with that, like we support functional programming, and you can force functional programming, whereas Rust goes like, yeah, but lifetimes, and you go, oh, damn it, right? And like one example I had is when I got started, I was like right before the 2021 edition, right? Const generics had just come out, and I was like, I'm gonna get on that. I'm gonna see what's going on. And I tried to make const generic rational types. Horrible. Like you find out that, like you're actually not computing over one type. You're computing over infinite types almost, and like. How do you make all infinite types work with all other infinite types? And you go, I'm doing this wrong, right? But it has a use, right? It's just not, you shouldn't do that, right? There were some other things, like, to be perfectly honest, like I know some people, they understand variance, and I'm still looking at it, I go like, it's not clicking. I revisit it, it's not clicking, but it's okay. I can get something useful and working, and I have a certain understanding, and it's still, yeah. You don't need to know everything in the language to make something that's useful, yeah.
Last question, to give our next presenter some idea to work with, or multiple ideas, what's something that you would love to see here talked about?
I think what would I really like to see talked about? I would like to see how we can take ideas from like the 70s and 60s and see how they work in like a modern, strongly typed language, right? Because there are a lot of really interesting ideas, dealing with like Lisp or Prolog and other stuff like that. Like there are little implementations here and there, but people don't really talk about it and they just assume it's not useful. Like, and yet, for example, the implementers of Rust, for example, use like versions of Prolog and Datalog to check the borrow checker in the trait system. And yet, no one knows what Datalog is, despite the fact that there's tons of research on it. So it'd be nice if we knew, like, what are they thinking back there, right? What's going on? Like, yeah, I don't know. I'm kind of I like esoteric things, so I think the next presenter, though, should probably make it a little bit less technical than mine, and hopefully one they can actually finish by the end, so, yeah.
That sounds good to me. Thank you.
All right.
Thank you for the presentation. Thank you for coming to the Tokyo Rust meetup. See you all next year.